In this clip we're going to look at multimeters and how they're used in circuits and physics. I will also look at how multimeters can be used to do a little fault finding. Here's a simple circuit with two light bulbs connected together in series. I'm going to measure the current in the circuit. To measure the current, I'm going to have to set my multimeter to be an ammeter. My leads are connected into the black and red DC sockets of my power supply, so I'm going to set my ammeter to DC. If I was using a battery, I would also be setting my ammeter to DC. There are a whole range of different current settings on my ammeter. Now the best thing I can do is to start with the biggest setting, which is the 10 amp setting. So I'm going to move a selector dial to 10 amps. I also have to think about the sockets that I'm going to use. There's a socket if I've set the selector to 10 amps, and I will always use this COM or common socket for one of my leads. Ammeters measure the flow of electric charge through a circuit. To be able to do that, I have to break the circuit to let the charge flow through the ammeter. Are we happy with that? Well, nearly. It's reading negative. How could we stop that happening? The easy way is simply to swap these leads around. Now we see that it's reading the same size of current, but it's reading positive. If I was making a measurement like this, and when it's put the ammeter in the circuit, I got a very low reading or even a zero reading on the screen there, I would then have to try one of the other settings. But I wouldn't try and change that selector dial while the ammeter was connected to the circuit for two reasons. One, I would be using the wrong socket. Secondly, ammeters have been known to be damaged by changing the readings while they're still connected up to circuits. The next measurement I'm going to make is of the voltage or potential difference across one of the bulbs. This time I've put my leads into V and COM, and I've set my selector dial to 20 volts. That's usually suitable for most school applications. When you talk about measuring voltage or potential difference, you should really talk about measuring the voltage across a component. Now that helps you to realise the way you should connect the meter. You're going to connect it across or in parallel with the bulb in this case. Now because of that, you need stackable leads, the kind of lead where one lead plugs on top of another. So there we are, we're going to measure the volts across this bulb, the potential difference across the bulb. Now here my circuit isn't working properly, and I'm going to use the multimeter to try and find out what's wrong with it. Now you can see that the little light in the power supply is on, but that doesn't actually mean that the power supply is giving an output. So I'm going to check it with my voltmeter. Well, that seems to be fine, so now I'm going to check the wires and the bulbs in the circuit. And to be able to do that, I'm going to set my multimeter to measure resistance. I've turned the selector to 200 ohms, and I'm going to use the V and COM sockets again. Resistance is a measure of how hard it is for electricity to pass through a substance. So when I've got an air gap, see that air gap there, it's very hard for electricity to get through, so I get a very high resistance. In fact, the resistance is off the scale. That's what that 1 in the left hand corner means. It means that the resistance is too big to be shown in the ohm meter. I can test each of my wires by plugging them into the ohm meter. Now wires are supposed to let electricity flow through them easily, so they shouldn't have a big resistance. As you can see in this case, they don't have, so that wire's all right. This bulb has a resistance of a few ohms. That's what I'd expect from a bulb, so I'm quite happy that this bulb's all right as well. On the other hand, when I try to measure the resistance of this bulb, the resistance goes off the scale again. So I reckon that that bulb's blown. I think that's the culprit. That's what was stopping my circuit working. If you've got an ohm meter and it goes off the scale when something's connected to it, the chances are that the thing that's connected to it is faulty. If you've got something that isn't a bulb or a lead connected to the ohmmeter, it might be worth trying to see that you're not getting a reading on one of the higher resistance scales. Never connect an ohmmeter across a component that's already connected to a circuit. For example, I wouldn't try and measure the resistance of a bulb with the ohmmeter connected across the bulb when it's switched on in the circuit just now.